In this video, you will learn some of the basics of sketching and creating simple parts in SOLIDWORKS. A central concept behind creating effective sketches is that of design intent. Design intent is how your model behaves when dimensions are modified. SOLIDWORKS captures the intent of your design using sketch relations, dimensions, and model features, as you will see in the following examples. First, let's define what are relations. Let's create a part. Go to New, Part, and click OK. The following screen should show up. If you've watched our previous videos, you should be familiar with the graphical user interface of SOLIDWORKS. You can see the command bar up here with various features that you can see in the Features and Sketch tabs. Here's the Control toolbar, and here is the Feature Manager Design3. Let's begin by learning how to first define a sketch. Sketches, by definition, are two-dimensional, which means that sketches need to be made on a plane. So, as you note here on the far left side of your screen, there are three different planes which are by default included in any given part. These are named the front plane, the top plane, and the right plane. These three planes all go through the origin. You can create sketches in two different ways. First, you can pre-select a plane, for example, the front plane, by left-clicking on the front plane, highlighting it here in the graphical area. You can then go up to the command bar, go to the Sketch tab, and click on Sketch. Note what just happened in the graphical user area. The perspective changed so that you are now looking normal to the front plane. Another way to create a sketch, which is entirely equivalent, first I'll X out of this by hitting this red X button shown in the upper right corner of the graphical area, which discards the current sketch. Last time I pre-selected the front plane and then hit Sketch. You could instead first hit Sketch, at which point you will be prompted to select a plane on which to create your sketch. In the current view, it's easy to see the front plane, but not so easy to see the top or the right planes. You could rotate the view in order to better see those planes. Or you can click here on the Feature Manager flyout, which exists here on the upper left portion of your graphical pane. Hit that little plus button. That will expand the flyout and allow you to select the front plane, the top plane, the right plane, or any other features that may exist in your part. Again, I'll click the front plane. The perspective is again adjusted so that we are looking normal to the front plane. And now we are free to begin sketching. If you turn your attention to the command bar, you'll note that on the far left, your first button says Exit Sketch. If you see the words Exit Sketch, it means that you are currently editing a sketch. The second button, Smart Dimension, allows us to create dimensions, such as defining the length of a line or the angle between different lines. In the next region, we have different drawing tools. You can create lines, circles, splines, which are essentially free-handed curves, rectangles and squares, arcs, ellipses, and a variety of other shapes. Lastly, you can also create points. There are a variety of other tools that you can use to modify your sketches, first including trim entities, mirror entities, linear sketch patterns, and more. I suggest you go through some of the tutorials to learn more about sketching. Let's begin by creating some lines. I'll hit the Line tool, and now I can insert a line anywhere within the graphical area. You'll note that the cursor has changed. Previously, now if I right-click and hit Select, our cursor was a normal mouse cursor. Upon hitting the Line button, we are now going to be inserting a line, and the cursor is changed to a pencil with a glyph under it. That glyph is a line. That tells you that we're now ready to create a line. You can start by placing the first point of any line anywhere in the graphical area. In this case, I'm going to place the first point of the first line on the origin. You'll note that when I place the cursor over the origin, another glyph has appeared. A glyph is the small graphical element that appears next to your cursor. If I move away from the origin, you'll note that there are no glyphs. When I move to the origin, a glyph has appeared. This glyph is the coincident glyph. Coincidence means that there is a relation. The relation means that the point that you're about to place is going to be coincident with the point that already exists in space there, that being the origin. If I click once, I can start my line, the endpoint of that line being coincident with the origin. Now when I start to move around the mouse, you'll note that several things can happen. If I were to place the cursor directly to the right of the origin, you'll note that there is a glyph. The glyph looks like a simple horizontal line. That horizontal line is what's called a horizontal line relation. In other words, if I place a point here, now there is a relation between those 2 points. That relation shows up as a horizontal line glyph, which says that that line that connects those 2 points will always be horizontal no matter what changes you make to your sketch. If I were to make another line and rotate about, you'll notice a few things. First, there are 2 dashed yellow lines. SOLIDWORKS by default creates 2 sets of lines for you, one that is parallel to the direction of the previous line and one that is perpendicular to it. This allows you to easily create new line segments along the same line or at a perpendicular angle. You'll note next to the cursor there are 2 numbers. The first number is a number of length. This length reads 20.68. Those are in the units that are native to the document. In my document here, those units are in millimeters. Units are important, and I'll show you in a moment how to change from millimeters to inches and back again. The second number is in angular units, in this case 90 degrees. You can also note that there's a glyph. That glyph is a vertical line, which means that there is a vertical relation between the point I'm about to place and the previous point, or that the line connecting the 2 will always be vertical. So I'll go ahead and click, and I'll make another line. Another line here, for example, exists at a special angle. In this case, there is an angular glyph, and it notes that there's a line of length 32 units, those being millimeters, and the angle of this line is at 135 degrees relative to the last line that you drew. That sounds okay. I'll place a mark here. And then, to stop drawing lines, you can either hit the Escape key on your keyboard or right-click and hit Select. That exits the Insert Line command. You'll note that we have a few lines here and a few glyphs. There's a coincident glyph, which notes that the point here is coincident, in this case, with the origin. There's a glyph here for horizontal, indicating that this line that connects this point and this point will always be horizontal, no matter what changes I try to make to the drawing. Similarly, there's a vertical glyph here, indicating that this line will always be vertical, no matter what changes I try to make to the drawing. You'll note that the lines are 2 different colors. This line here is black. These 2 lines are blue. Any entity, whether it be a line, a circle, or any shape, will appear black when it is fully defined, meaning that all the degrees of freedom have been satisfied. You do not need to make any changes in order to fully or further define this shape. It's fully oriented in space. These 2 entities are blue, meaning that they are underdefined. Underdefined merely means that they are not yet fully defined, and that if you were to make changes to your sketch drawing, you may find that these are no longer held in their current lengths orientations. Let's go ahead and add some dimensions to this sketch. You can go to the Smart Dimension tool, And when you go back to the user pane, you will find that the cursor has changed. It's a select cursor with a new glyph, that glyph being the dimension glyph. I'm going to go ahead and click once on this line. When you're passing over an entity with your Smart Dimension tool, it will change to let you know that you're currently selecting a line. In this case, this horizontal line. I'll left click once and move the dimension somewhere where it's easy to read, and click once on the left mouse button one time. This brings up the Modify Properties bar. It allows you to set what is this length. Right now, the length is 33.1739, etc. millimeters. I'm going to change this unit. How about 50 millimeters? Sounds good. When I change that, this is what the sketch now looks like. This line is now 50 millimeters long. If you don't want to work in millimeters, you have a few options. First, I'm going to right-click in the graphical area and hit Select to leave the Smart Dimension tool. On the lower right-hand corner, you will see a unit here that reads on my screen MMGS. It may read Custom or IPS depending on your user settings. This is a bar here that allows you to quickly change the units of the currently opened document. If I click on this button, you will have a few options: to use meters, kilograms, and seconds as your standard units, centimeters, grams, or seconds, millimeters, grams, or seconds, or an imperial system, in this case inches, pounds, and seconds. It's very important to take a look at your unit system first before you start adding dimensions of certain units. If all of the dimensions in a given sketch are going to be in inches, it's a good idea to set these as your document units. In this case, I'll leave it as millimeters. Let me add another dimension, this dimension being the height of this line. I'll change this now to say 100 millimeters. Note that you can write in the units or you can omit them, which will then SolidWorks will assume that you have the default unit. Green check mark, and that changes the sketch. I'll now zoom out to note that this length is now 100 millimeters. Note that it maintained a vertical relation. Let's set the length of this line. In this case, depending on where your mouse is, you can either set the total length, in this case which reads 48.23, or a projected length. In this case, the projected length along the y-axis being 34.10, or 34.10 along the x-axis. I'll define the absolute length, and instead of writing it in millimeters, I'll write it in inches. In this case, I'll say 2 inches by writing 2 and then the unit IN for inches. I'll then click OK, and note that it doesn't read 2 inches, it reads 50.80 millimeters. In other words, SolidWorks can convert units for you on the fly. It will always display the proper units, or at least the default units, in this case being millimeters. Now we note that there's still a blue line here. We haven't yet fully defined our sketch. We can, for example, set an angle. That angle between this line and this line. In this case being some sort of angle. I'll leave it at 45 degrees. You could have, alternatively, if I were to delete this, create a dimension between this line and this line, which then creates the following angle. You can write it as 135 degrees, for example, between these two lines, or as 45 degrees, which is just the complement of 135. I'll do it as 135 degrees, and click OK. Now we note that the sketch is fully defined. Once you're happy with your sketch, in the upper right hand corner, you can click the following icon to accept the sketch. You'll now note that there's a sketch called Sketch 2 that exists within your feature design tree. I'm going to now go back and edit my sketch by right-clicking on Sketch and going to Edit Sketch. You can also edit the plane on which the sketch is drawn. If you can recall, we drew this sketch on the front plane. If I instead wanted this sketch to exist on the top plane, I could then go to Edit Sketch Plane, select Front Plane, and delete that. Go to the flyout, and select Top Plane, and click OK. If I were now to change my view to look down on Sketch 2, normal to the top plane, I can click once on Sketch 2, go to the View Orientation control box, and click on Normal to. Normal to will then look appropriately at the angle perpendicular to the plane on which this sketch is drawn. In this case, it would be the top plane. If I wanted to edit my sketch, I can right-click on the sketch, and the first button reads Edit Sketch. If I click that once, we're back to editing our sketch. I'm going to go ahead and delete everything. There's two ways you can select things in SOLIDWORKS. If you click and hold and drag from right to left, you get a green selection box. When you have a green selection box, any entity that falls within the green selection box will be selected. So in this case, I have two entities that are at least partially within the green box, and so it selects those two entities. If instead you were to click and drag from left to right, you'll get a blue box. In a blue box, you will only select those entities that are entirely within the box. In this case, we have one entity, being the line that's angled at a 135-degree angle, that's entirely within the box, and the vertical line, which is only partially in the box. So we will only select the top line. I'm going to select everything and delete it. It's as if we're starting from a fresh sketch. Let's look at an example. I'm going to create a simple rectangle with the first point coincident with the origin, and then a second point located somewhere out here. I'll then click Escape to leave the rectangle draw tool. I'll click on Smart Dimension, and I will dimension those lines that are shown in blue. In this case, this length I'll make 100 millimeters, and this length I'll make 100 millimeters. And you'll note now that a rectangle is all with black lines and black points, indicating that it is fully defined. If I were to delete one of these dimensions, you'll note that the points and the lines on this side are blue, meaning they're not fully defined. Similarly, if I delete this, this other line is not yet fully defined. If I reapply them, our sketch is again fully defined. It is only by the combination of these two dimensions and the 5 existing relations, that is, that this point is coincident with the origin, that this line is horizontal, that this line is horizontal, and that these two lines are vertical, that this now square is fully defined. SOLIDWORKS will often automatically place these relations for you, or we can manually place them, as you'll see in a moment. I'll now start to add another element to this sketch. Let's put a circle in here. I'm going to place this circle roughly in the middle. Let's go ahead and dimension this circle by going back to the Smart Dimension tool. Let's first set what is the diameter of the circle. In this case, I'll make the diameter of the circle 50 millimeters. The circle is not yet fully defined. It appears in blue because while we have defined its diameter, we haven't yet defined its position. So we must say, where is the center of this located? For example, I can say that the position of the center and this line are a certain distance apart. In this case, let's say 25 millimeters. Now, you know what? I'll change that. Let's make it 50 millimeters. Again, we're not fully defined. I'll go ahead and click the center again, and perhaps this line, and dimension that. Let's make this 50 millimeters. Now we've fully positioned the circle. In other words, all the lines are now shown in black, which means they are fully defined. Since we have a fully defined sketch, now we can go ahead and create a simple feature. I'm going to click this button in the upper right to accept the changes to the sketch. And you'll note that we now have a sketch that exists on a plane, that plane being the top plane. Now we have to create a feature. Let's go over to the Features tab on the command menu, and we'll note that we have a number of options available to us. We could extrude, we can revolve. We could also do a few other features that we are not yet going to talk about. I'm going to pre-select our sketch, and I'm going to click Extruded Boss. The property manager for this feature shows up on the left-hand side. It asks us how we want to extrude. We'll go over this a little bit more in a moment. For now, I'll leave it as it is. I'll hit the green check mark for OK. And you'll note that we now have a three-dimensional part. Now suppose I want to make a change. Perhaps I didn't want it to be 10 millimeters deep. Suppose I wanted to make it 25 millimeters deep. You can always go back and edit your feature. The feature now appears in your feature design tree. If you were to right-click once, on the top portion here, the first icon reads Edit Feature. The second icon reads Edit Sketch. Let's see what each does. Edit Feature allows you to go back to the property manager for that feature and modify the conditions that you used. In this case, if I were to make this 20 millimeters deep, or any other number, I can modify that and click OK. Suppose we wanted to make a change to the sketch that was used for this. We can always do that. There's two ways to do it. You could directly right-click on your feature and click Edit Sketch. Another way would be to click first this plus mark that appears to the left of your sketch. That plus mark allows you to expand the underlying sketches that go into your feature. For an extrusion, you only need one sketch. For several other features that we'll see later in this course, you may need more than one sketch. But these sketches are not fully the property of this feature. You can use these sketches again and again for any other features that you'd like. So in this case, I can right-click directly on that sketch and click Edit Sketch. We can now go ahead and edit our sketch, but we also see this projected view of the extrusion, which makes it a little bit difficult to see exactly what we're editing. Let's go ahead and look normal to the sketch again by going to the view orientation and clicking Normal to. We're back at our sketch. What would happen if I wanted to change the dimensions of this square from 100 millimeters on each side to 200 millimeters? Well, let's find out. I will double click on the dimension that already exists and modify it from 100 millimeters to 200 millimeters. And similarly, I will change this dimension to 200 millimeters. This is the resultant sketch. Is it what you expected? The center of this circle here continues to exist at 50 millimeters from this edge and 50 millimeters from this edge. Suppose that's not what you wanted. Suppose you wanted the center of this circle to always lie within the center of this square, regardless of the dimensions of the square. How would you go about doing that? This is what we mean by design intent. Let's revert our change by making the sides again 100 by 100. There are many different ways to convey this design intent. I'll show one possible method. First, I'll go ahead and delete these dimensions because they don't convey the proper design intent. Now, we can add relations in order to force the center of this circle to always exist in a position of our choosing. One possible way to do this would be to create horizontal and vertical line relations that connect this point with the midpoint of this line and the midpoint of this line, such that whenever these length dimensions change, the center of this circle will move to coincide vertically with the midpoint of the top line and horizontally with the midpoint of the right-hand line. We'll need to do two things in order to do this. First, we'll need to add 2 points. Let's go ahead and click on Point and place a point in the center of the top line. You'll note that when you carefully place your mouse cursor, you get a glyph. This glyph, if you look carefully, is the midpoint glyph. Click once to add that point. Let's repeat that procedure on the right-hand line. We've now added 2 midpoints. Go ahead and click OK. And let's go ahead and hit Escape or right-click and hit Select to exit the Draw or Add Point tool. Now we need to add a couple of relations to be able to convey that this point and this point are always vertically related to each other, and that this point and this point are always horizontally related to each other. You can do this by holding down the Control key and selecting the 2 entities that you wish to relate. In this case, it will be the center of the circle and this midpoint. Look on the left-hand side. You'll note that you have 2 selected entities, called, in this case, point 12 and point 13. Note that there are no existing relations between these points. SOLIDWORKS gives you a convenient tool to be able to add these new relations between these entities. By default, SOLIDWORKS will attempt to figure out what kinds of relations you can add between the 2 entities that you've selected. And it's come up with the following 4 options. You could add a horizontal relation, a vertical relation, a coincident relation, or a fixed relation. The horizontal relation would state that the position of this point and the position of this point are always joinable by a horizontal line. In this case, that's not what we want. We want a vertical orientation. SOLIDWORKS has bolded the vertical orientation for us. It's done this by saying which relation would change the current sketch the least. In this case, that's the vertical relation, and it happens to be the one that conveys our design intent. Go ahead and click this button once, and you'll note that a vertical relation has been added between these 2 entities. Click OK. Let's repeat this procedure for the 2 lines that will have a horizontal relation. We will hold down the Control key, click the center of the circle, and click the midpoint on this line. There are no existing relations between these 2 points, and we'll add a horizontal relation. As soon as we do that, the color of this circle has changed from blue to black, indicating that it is now fully defined. Now let's see what happens when we change the side lengths from 100 to 200 millimeters. You'll note that the center of the circle now is within the center of the square. This now properly conveys your design intent, if that indeed is your intent. We can again click OK to accept these changes, which then propagate onto our boss extrusion feature. Now that we've introduced the basics of sketching and previewed one simple feature, that being an extrusion, let's spend a few moments to go into further detail in extrusions and revolutions. I've prepared a document here that can help illustrate some of these. The following is a model that can illustrate some of the fine points of the options you have available to you when extruding or revolving a feature. Let's start first with extrusions. I will take this sketch right here and extrude it outwards. First I'll click on the sketch and click on Extruded Base. By default, SOLIDWORKS wishes to extrude using an end condition called blind with a depth of 10 millimeters. If we hit OK, we'll note that now there's an additional solid model that's been merged into the existing model. If I change the shading here, you may have a better sense of that. When you extrude in the blind condition, SOLIDWORKS doesn't care what solid geometry might be impinged by the current feature. In other words, this may overlap with existing geometry, which may not be your intent. The new extrusion that we just created exists now as Boss Extrude 6 in the Feature Manager. If I were to right-click that, we can go and edit that feature at any time. If I go back to edit that feature, you could, for example, change from 10 millimeters blind extrusion to 20 millimeters blind extrusion. If you click OK, you'll note that now we have a 20 millimeter extrusion. There are some options here that allow you to better extrude. If I right-click on this feature again and edit the feature, we note that our first option here is End Condition Blind. If we click on this drop-down menu, we'll note that we have a few different end conditions. Some of the more important ones for your work include Through All, Up to Next, and Up to Surface. Let's take a moment to see what each does. A Through All end condition does exactly what you think it does. It extrudes through everything. It stops when your model no longer has any solid geometry. No, it doesn't extend out into infinity. If you click OK, you'll see that this is the extrusion that now goes through the entirety of your solid model. Let's go ahead and edit this again. And instead of clicking the Through All end condition, we can try the Up to Next end condition. Up to Next means that the extrusion will continue until any solid feature is impinged. In this case, that's this face right here. And the extrusion stops once it hits this face. That's a pretty handy tool. Let's edit one more time and highlight what Up to Surface does. When you click Up to Surface, you need to define one more input, that being the face or the plane, in other words, which surface you wish to extrude to. In this case, let's select this surface. When you select that surface is now shaded in a pinkish color, and the extrusion goes up to that surface. You can select another surface by clearing this selection and clicking another surface. For example, this sloped surface. You'll note that when you extrude up to a surface, you will extrude up to all points that impinge upon the current cross-section onto the sloped surface. I'll go ahead and delete this by right-clicking on the feature and going down to Delete. When you do this, it will ask you to confirm the delete. I'll click Yes. And you'll note that the original sketch is still existing on your part. Now let's take a look at another kind of extrusion called an extruded cut. The extruded boss or base adds material while the extruded cut removes it. We'll use Sketch 5, so I'll select it once and click on Extruded Cut. We have similar end conditions to choose from now, the first being blind. If I click OK, you'll get a blind cut. In this case, I'll look at a wireframe, and you can see that there is indeed a blind cut that goes into the material. If that's not what you wanted, you can go back to the cut feature that was just created, right-click, and edit the feature. We can change the end condition from blind to through all, or up to next, or up to surface. through all cuts through everything. Or you can go up to next, which cuts through to the next surface. You can also cut up to any surface you choose by using the up to surface end condition. For example, I can select this surface, which then only cuts up to that surface. Now that you've seen extruded bosses and extruded cuts, let's take a look at some revolutions. I'll go ahead and delete this feature. Let's first look at a revolved boss or base. I'm going to use this sketch for this purpose. This sketch exists on this face right here. Once you click on the sketch, you can click on Revolved Boss / Base. You'll have to define two things. Most importantly, you need to define an axis of revolution. On this drawing, I'm going to select this edge as our axis of revolution. If I click OK, you'll note that we've now created new material that has been merged with the original material that was made by taking this sketch and revolving it 360 degrees around this axis, being coincident with this edge. If you don't like that, you can always go to the new feature that was made, in this case, Revolve 1, and edit the feature. Perhaps you didn't want to rotate 360 degrees. Perhaps you only wanted to go 180 degrees. You can make that modification and click OK. Now let's look at a revolved cut. For that purpose, I'll use this sketch, located right here. This sketch is drawn on this plane. I'll click on that sketch, and then click on Revolved Cut. Again, for a revolved cut, we must define an axis of revolution. For that purpose, I will select this axis, being coincident with the edge shown here. If I accept a 360 degree cut, click OK, we get the following. We can go back and edit this feature and, for example, change the axis of revolution. Perhaps that's not the edge we wanted to revolve around. I'll go ahead and right click and clear selection. Suppose it was this axis. Ah, okay. Click OK. We get instead that feature. Let's take a look at one other feature that may be handy, which is called the fillet feature. A fillet rounds a sharp corner that exists between at the intersection between two faces. The fillet feature exists right here. Fillets don't require any sketches. All you need is some solid geometry. If you click on the fillet feature, it will ask you, what do you want to fillet? And what kind of type of fillet do you want to use? The easiest way to create a fillet is to select the edge that represents the intersection between the two faces that you want to fillet. For example, if I were to fillet this edge, rather than being a sharp corner, we can round it. I can click on it once, and you'll note that it gives you a preview. If I then rotate my view from the top, you can see that it wishes to round the corner with a radius of 10 millimeters. Perhaps that's a bit too big. How about I go ahead and change this down to about 2 millimeters? Ah, okay. You can see that we've rounded the corner. Click OK, and you'll see that you now have a nice rounded corner on this edge. It's done so by removing excess material. fillets can also be used to add material. For example, along this edge right here, there's a sharp 90-degree edge. That's very difficult to machine. If I were to hit fillet and select this edge, you can now create a rounded corner, which will, in this case, add material. Lastly, I want to highlight something called reference geometry. You've noted at the beginning that there are 3 planes on which you can, by default, create new sketches: the front plane, the top plane, and the right plane. Once you've started creating new solid geometry, you can select any of the faces that exist on your solid model to draw new sketches. But these faces are not always appropriate and don't always get the job done for the task that you envision. Sometimes you need a plane that's located somewhere else to get the job done. In this case, you might want to learn how to create a reference plane. You can do so by going to your Features command menu, clicking on Reference Geometry, and then selecting Reference Plane. To create a reference plane, you need up to 3 different references. If you recall back to your geometry training, a plane in 3-dimensional space can be fully defined in a number of ways. The simplest way is to define that plane relative to another plane. So for example, if I were to click on this or expand out the fly menu here that shows the different features that exist in the part, I could select one of these planes. For example, I can click the front plane as our reference. By default, SOLIDWORKS will want to create a plane that is perpendicular to the front plane but is offset by some distance. You can set what that offset distance is, in this case 10 millimeters. If we say OK, we've created a new reference plane, and we can draw sketches on this plane. This plane being at a different position than any plane that currently exists on the model. There are other ways to create reference planes. For example, instead of using a plane as your reference, you could use a line. But one line is not enough to fully define a plane. You need some other references. There are different ways to choose other kinds of references. For example, you can use 2 intersecting lines to define a plane. In other words, there's one unique plane that contains any 2 intersecting lines. Or you could use a line and a point. So long as that point is not collinear, or in other words, exists along the same line, then there's only one plane that would go through that line and through that point. Or rather, that I should say, to be more precise, that fully contains that line and goes through that point. You can also select 3 points, so long as no more than 2 of those points can be joined in a single line. So for example, I've already selected one edge. Now I just need to select a second edge that exists or that intersects this edge right here, or at least the line that does. If I were to select this edge, for example, you now note that we fully defined our plane. In other words, the line that extends from this edge will intersect the line that constitutes this edge, and that fully defines this plane. Of course, that's not an interesting plane because that plane already exists right here and right here. You could create planes that exist at different angles. For example, I've drawn a plane here called plane 1. If I were to go ahead and click Edit that feature, it goes back to your reference plane property bar, and you can see how I created this plane. I simply clicked on this sloped face and said that this new reference plane exists at a 15-degree angle relative to that face. But that doesn't yet fully define it, because that many planes can exist that are parallel to each other that are all at that angle. You need not only that angle, but what edge is contained on that plane to fully define not only what its orientation in space is, but what is its position. you may find that creating reference planes are a very handy tool to create some of the complex geometries that you may see in certain parts. I encourage you to practice with this and with many of the other features that you've seen in this video to get a better handle of how you can create parts from just simple building blocks such as extrusions and revolutions.